Hey guys, Ms. Gosling here. In this video, you are going to learn about the magnetic fields and forces that arise due to currents. By the end of this video, you will be able to describe the magnetic fields and forces for current-carrying wires. Let's go ahead and get started. Now, when we are trying to figure out the magnetic field around a current-carrying wire, what we're going to do is use something called the right-hand rule. And what you're going to want to do is make a thumbs up with your right hand, not your left hand, your right hand. That is very, very important. If you're using your left hand, this is going to not give you the answer you want. So you're going to make a thumbs up with your right hand, as you can see that I have done over here in the corner. And what you're going to do is you are going to take your hand and line it up so that the thumb is in the direction of the wire, and your fingers are wrapping around the wire. So here you go, you can see I have taken my hand and I have wrapped it around the wire. Okay, so now that my thumb is lined up in the direction of the wire, my fingers are showing me the direction of the magnetic field all around the wire. So what you can see is that our magnetic field is wrapping around the wire in the same way that my fingers are wrapping around the middle of my palm. So what I'm going to do is I'm going to draw the magnetic field in 4 different places on our wire. I'm going to start by drawing the magnetic field at the front of the wire, and then we'll talk about the magnetic field at the back of the wire, the magnetic field on the top of the wire, and the magnetic field on the bottom of the wire. So in the front of the wire, that's my easiest to see. You can see that your fingers are pointing down. So back of the wire, or the front of the wire, my magnetic field is pointing down. And that's the side of the wire that's closest to me. On the back of the wire, on the other hand, you can see your fingers are going up. And so on the back of the wire, your magnetic field is going up. Now, on the top of our wire, our magnetic field is coming into the page, or coming out of the page. And you can see that because your fingers are going out of the page at the top of this image. The way we are going to represent coming out of the page directionally is with dots. So this is the top of the wire. And at the top of the wire, our field is coming out of the page, and again, we're using dots to represent that. Finally, on the bottom of the wire, our field is going into the page, and we are going to use the letter X to represent going into the page. The way that I like to remember how to represent going into the page and out of the page is I like to think of an arrow. So if you have an arrow, you've got your arrow that's fletched on the back, right? And you've got its point at the front. If an arrow is coming towards you, if it's coming out of the page towards you, what you're going to see is you are going to see just the tip of the arrow, and it's going to look like a dot. However, if it's going into the page, away from you, what you'll see is you'll see that fletching on the back of the arrow, which often looks like an X. So that's how I remember that that a dot is into the page and an X is out of the page. So with that, let's go ahead and move forward. And to move forward, we're going to look at example 1. For example 1, we are going to figure out the magnetic field around a wire carrying a current coming out of the page. And you can see that I've represented this wire and this current with a dot, because remember, a dot represents something coming out of the page. Now what I want you to do is go ahead, take your hand, take your right hand, make a thumbs up, and stick it on the screen with your thumb coming out of the page. And what you'll see is you'll see the direction that your fingers are going in around your thumb. And what you should see when you do this is that the direction of your fingers around your thumb are as follows. So your fingers are pointing towards the left, or down on the left side of our current, and then to the right, up, and back left. So here's going to be the magnetic field for a wire carrying a current coming out of the page. And I should have drawn these as concentric circles. I am not great at drawing circles, which is why they kind of look a little bulbous. But when you're thinking about drawing currents, if you're being precise, you are going to want to make sure you're drawing your field lines as circles. Now let's talk about the magnetic forces between wires. So what I'm going to do is I'm going to go ahead and start by using my thumbs up to draw the magnetic field around both of my wires. So on my first wire, I'm going to just draw the top and the bottom. So again, on the top, we are coming out of the page. And on the bottom of my wire, my field is going into the page. Similarly, I can go ahead, I can pick up my thumb. You can see I'm dragging some of the field with me, but that's okay because guess what? The electric field is going to be the same on the other side of my wire. The top of my wire is going to be coming out of the page, and the bottom is going to be going into the page. So let's go ahead and draw that, and I'm going to go ahead and fix my top wire as well. So what you can see from this is that the direction of my magnetic field on my top wire is exactly the opposite of the direction of my magnetic field on the bottom wire. And so what this is like having a north pole and a south pole of a magnet next to each other. And so my two wires going in the same direction are going to attract one another. So the force on wire 1 looks like this, and the force on wire 2 looks like that, where this is wire 1 and this is wire 2. This is the force of wire 2 on wire 1 and the force of wire 1 on wire 2. So again, when we have two currents traveling in the same direction, those two currents are going to experience an attractive magnetic force. Now let's look at two wires going in opposite directions. And this time I have a wire going out of the page and a wire going into the page. And I'm going to go ahead and draw the magnetic fields for both of these wires. So out of the page, we've already seen our magnetic field looks like this. For my current going into the page, my field lines are going to go in the opposite direction. I'm going to start by just drawing the circles for them, because again, the shape is going to be the same. But what they're going to look like is we are going to be going down to the left, up and to the right, down to the left, up and to the right. And what we care about is this space right between our two currents. And you can see here that the magnetic field lines on that side of our two current carrying wires is actually pointing in the same direction. And so this is like having two north poles or two south poles together. So if our field lines are pointing in the same direction, between our two wires, what that means is that they are going to repel from one another. So what we're going to have is we're going to have the force. I'm going to call this current 1 and current 2. So the force of current 2 on current 1 is going to push it to the left, and the force of current 1 on current 2 is going to push it to the right. Now, this is a little confusing, right? So we're used to like things that repel and unlike things attract. And when our current carrying wires are the same, they will attract, and when they're in opposite directions, they'll repel, which is a little different from what you're used to. But what's important is to remember that the direction of our field lines is what defines our north and our south pole. So if our field lines are pointing in the same direction, that means we have either two north poles or two south poles, kind of, and that our two forces, our two magnetic fields are going to be repulsive to one another. So takeaways. We can use the right-hand rule to draw magnetic field lines around wires. And secondly, like currents attract, opposite currents repel. I'm going to go ahead, I'm going to do a little color. Like currents attract and opposite currents repel. And those are your takeaways. So go ahead and give it a try. Best of luck and happy solving.